Good. All right. So, ladies and gentlemen, what I'm going to do is I am going to continue with what we kind of went off before Thanksgiving break, as well as what some of you, Taylor, that were not here, Taylor and Taylor, that were not here for the last class we were before break, where we were graphing equations. And if you guys remember, we graphed equations. And then we also, the last thing I left you guys off with, just choosing test points. But basically what today we want to be able to use is how are those test points going to help us kind of like represent the solutions? All right? So how are we going to use the test points? What are we going to be able to do? So what I'm going to do is I'm just going to do a quick little review of how to graph again, just as we've gone through this, the review kind of session on how to graph. And then we'll go back through the test points, and then I'll explain why exactly or how we're going to use test points to help us finalize our answer. So when we're graphing an inequality, remember the main important thing is to think of an inequality just like an equation. Just what you guys have learned in Algebra 1, Algebra 2, and at the beginning of this chapter is, graph this. We can use intercept method, or what we've pretty much focused on in this class is rewriting this in slope-intercept form, which is just like we did for solving literal equations. So the first thing we're going to do is put this into slope-intercept form, which means I need to solve for y. So I need to get the y by itself. So to do that, I'm going to use my inverse operations by adding an x to both sides. Therefore, I obtain 2y is greater than x plus 4. Does everybody see and understand why I wrote the x in front of the 4 rather than 4 plus x? Because I want to keep it like this format. So I want to write mx plus b. Then the last thing I need to do is divide by 2. So I have y is greater than 1/2 x plus 2. Again, ladies and gentlemen, please remember to take that 2 and divide it by both of those terms. Therefore, I have 1/2 x plus 4 divided by 2 is 2. So if you guys remember, the reason why we did this is so that we can identify the y-intercept and the slope. And the important thing about the y-intercept is the y-intercept we can represent as a point. So when we're graphing this, the first thing, if you're having trouble with the graph, that I'm going to tell you to do is first identify what the y-intercept is. And then the second thing is plot the y-intercept on the y-axis. Y-axis, x-axis. So in this case, you can see that my y-intercept is 2, but I can represent that as a coordinate point of 0, 2. So I go up 2 and make a nice big dot. Then my slope is, remember, we represent the slope as a fraction. So anytime you have slope that's a whole number, make sure you put it over 1. So you can always have it as a fraction. And remember, the slope represents the change in the y-coordinates over the change in the x-coordinates, or otherwise sometimes known as rise over run. So to find the next point, I'm going to go up 1. And then change in the y-coordinates is 1, so I go up 1. Change in the x-coordinates is positive 2, so I go over 2. 1, 2. Now, one thing that we did not discuss last class period was how to identify if our graph was dashed or solid. So you guys are definitely going to want to write this down, especially if this is something that you have forgotten in the past. So when we were graphing one variable inequalities, remember we had the open and the closed dots, right? And the reason why I had open and closed dots, because when it was an open dot, that means the point was not a part of the solution. And the closed dot meant it was a part of the solution. Well, when we have dashed or solid lines, when I have a dashed line, that tells me that any point that lies on the line is not going to be a part of the solution. And I'll explain that when we get into our test points. Where solid, it is going to be a part of our solution. Since this is a greater than and not greater than equal to, my line is going to be dashed. All right, so now let's get to where we were at last class period. Last class period, we discussed choosing test points. And the best test point, Jordan, the best test point, Jordan, to pick would be, do you remember? Starts with 0, ends with 0. Thank you, Sheldon. Yes, 0, 0 is the best test point ever to choose. Why? Because using arithmetic with 0, 0 is going to be very simple. However, we cannot use 0, 0 when it goes through, when our line goes through 0, 0. So what I'm simply going to do is test 0, 0. So I just plug, that's a coordinate point, x, y. So I plug 0 in for y and 0 in for x. Then I have 0 is greater than 2. So then I ask Macy, is that true or false? Is 0 greater than 2? False. So since that is false, that means all the points that are below the line are false, and that means all the points above the line are true. So that's what we're going to shade. So last class period, we just discussed determine if it was false or true. But what that means is that when we have a solution that is false, that means all the points are going to be false. And when we have a point that would be true, that means you always shade towards where it's true and away from where it's false. Anybody have any questions on the shading? No? OK. All right, that's it. I just got one more example for Brandon to make sure that he has this done.